Before you tackle optimization problems, you may need to review a few fundamental concepts.
These concepts include critical points, first derivative test, and the second derivative test.
Here is an example graph of graph f of x. Take note of the local max and min. Now let's see what happens when we draw in the derivative graph.
Notice when there is a max or min, the derivative graph is 0 at this point. This is because at critical points, the derivative is 0. In other words, the tangent at these points are horizontal, and therefore has a slope of 0.
This means we can find the critical points by setting f prime of x equal to 0.
Once you have found the critical points, you can determine whether they are a relative max or min by using the first derivative test.
Use the critical points to create a chart. This chart organizes the intervals between the critical points. The sign of the slope, plus or minus, can only change at critical points.
The first interval always goes from the lowest point to the first critical point. In our case, negative infinity to 0. Since there is only one critical point, the next interval goes from 0 to infinity.
We can determine whether an interval is increasing or decreasing by plugging in any value in that interval into f prime of x. For example, negative 1 and 1 come out to negative 2 and 2 by plugging in the numbers to f prime of x as shown above.
The sign of the intervals are then negative and positive, therefore decreasing and increasing.
If the slope, f prime of x, goes from positive to negative, the critical point is a maximum. If the slope goes from negative to positive, the critical point is a minimum.
Since the interval goes from negative to positive, our critical point, 0, 0, is a local min. We can see this in the graph.
Next is the second derivative test. The second derivative test may be a much faster method, however, may result in inconclusive answers, which will force you to revert back to the first derivative test. But this is how it works.
Let c equal the x value of a critical point. If f prime of c equals 0, and f double prime of c is greater than 0, then the minimum occurs at c. If f double prime of c is less than 0, then the maximum occurs at c. If f double prime of c is equal to 0, then the test is inconclusive.
Now we will do a cumulative review problem. We have the equation f of x equals x to the fourth minus 4x cubed. To find the relative extrema, we must first find the critical points. First, we find the first derivative. Next, we set the first derivative equal to 0. When we do this, we find that x equals 0 and 3. These are our critical points. Now we must find if they are maximums or minimums.
We will plug these points into the second derivative test. In order to do this, we must find the second derivative. When 0 is plugged in for c, we get that f double prime of 0 is equal to 0. The test is therefore inconclusive. And we must now try the first derivative test.
To do the first derivative test, we must separate our critical points into intervals. The first interval is negative infinity to x to 0 is less than x is less than 0. The next interval is 0 is less than x is less than 3. And the last one is 3 is less than x is less than infinity. Next, we must assign test points to test in each interval. We will use something less than 0 or negative 1, something between 0 and 3 or 1, and something greater than 3, which is 4. When we plug each of these into the first derivative, or f prime of x, we find that the sign is negative for negative 1, negative for 1, and positive for 4. The conclusion of this means that the graph is decreasing, decreasing, and then increasing. Because the signs of the first two intervals are the same, we know that there is no maximum or minimum at 0. However, at 3, because there is decreasing and then increasing, we know that there is a minimum.
We can see that if we had continued with the second derivative test, 3 would be found to be a minimum. By plugging 3 into the second derivative, we find that f double prime of 3 is equal to 36. Meaning that f double prime of 3 is greater than 0. According to the second derivative test, there is a minimum at x equals 3.
Graphically, we can see that there is no minimum or maximum at 0 and a minimum at 3.